Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We are moving into Chapter 3, which is Systems of Linear Equations and Inequalities. 3.1, the name of this lesson is Systems of Linear Equations. Should be Systems. Sorry about that. So let's go ahead and get into this right away. So we don't have a essential question, which I know you guys will be crushed about today. But basically, we're learning about checking whether different ordered pairs are solutions, and then trying to figure out solutions to linear equations by graphs. And the big moral of the story is that a solution to a linear system, graphically, is where the lines cross. Okay, so there's also some solutions where if it's the same line on top of itself, and also if it's like parallel lines, which we'll talk about in a little bit here. Okay. So, systems of linear equations is going to be two linear equations in the form, it actually could be two or more, but we'll stick with two for now. It's going to be in the form ax plus by equals c, and dx plus ey equals f. Okay. Also, I think when we're doing this lesson, we're not going to have we're not going to have note sheets for this chapter pretty much. So just do the best you can to take notes. I'll try to really highlight the stuff that I want you to take notes on while you're following along. But basically, what I would focus on is kind of watch the definitions and stuff and vocabulary on the video, but also like for these examples, try doing the examples for in your notes to kind of get some practice, because those are what are really going to matter, the examples, so you know how to do the problems. Okay, but we're going to be moving away from hard copies of notes probably, so you'll have to figure out a system for taking notes, which will probably be just like following along in the video and trying the example problems when we have example problems. Okay, so a solution is an ordered pair that makes all equations true and where the graphs cross. Okay, it's where the graphs cross. All right, so this is an example you're going to want to write down. We have determined the following ordered pairs are solutions for the system. We have 3x minus 2y equals 2, x plus 2y equals 6. We're going to plug in, we're going to do 2 and 2 for 1, which we'll try together, and then you guys will try 0, negative 1 on your own, okay? So what we're going to do, we have our two equations. Switch to a new color here, I like this color. So we're going to plug into the 3x minus 2y equals 2. We're going to split that. We're also going to do x plus 2y equals 6. Okay? So all we need to do is we need to figure out if this is going to be a solution. And the way we do that is we're going to plug this in for x and y. Like a label of point x and y, we're going to plug it in and see if it's true at the end or not. Okay? So we have 3 times x, which is 2, minus 2 times y, which is 2, equals 2. All right, let's simplify this now. So 3 times 2 is going to be 6, minus 2 times 2, which is 4, using PEMDAS. Working left to right, multiplication comes first. And 6 minus 4 is going to be what? That's going to be 2. Does 2 equal 2? It does. So that's going to be it's a solution for that one, but it needs to be a solution for all the different equations in the system. Okay, it can't just be true for one equation, it has to be true for all of them. So let's see if it's true for this one too. So we're going to plug in 2 and 2 for x and y again. So we're going to do 2 plus 2 times 2 equals 6. Now, do we do 2 plus 2 or 2 times 2 first in PEMDAS? We do 2 times 2. Multiplication comes first. So 2 plus 2 times 2, which is 4, equals 6. And then what's 2 plus 4? Does 6 equal 6? Yes, this is true. So these are both true, which means this is going to be a solution. It is a solution. Okay? All right, we're going to do the same thing over here. You guys are going to try this one on your own. I'll write out the problems first. 3x minus 2y equals 2 and x plus 2y equals 6. Why don't you guys go ahead and try 0, negative 1 and see if you guys get a result over there that makes sense, whether it's a solution or not. Give it a try. All right, welcome back. We're going to plug these in for x and y again. We're using 0 and negative 1. So we're going to do 3 times 0 minus 2 times negative 1 equals 2. 3 times 0 is 0. Negative 2 times negative 1 is positive 2. What's 0 plus 2 going to be? Does 2 equal 2? That one's going to be a solution for that one. Let's check the other one now. Okay, so we have, we're plugging in 0 in for x again. So 0 plus 2 times negative 1, which is y, equals 6. 2 times negative 1 is negative 2. So we have 0 plus, 0 minus 2 I'm going to put equals 6. And does negative 2 equal 6 or no? This is going to be not a solution. It needs to be true for all equations in the system for it to be a solution. Okay? All right. Good stuff. Okay, now we're going to do the same thing, but we're going to do it graphically. We're going to be looking for solutions by graphing. All right? So we have these two equations. We have negative 2x plus y equals 5, and we have x plus y equals 2. So first thing we need to do to be able to graph these is we need it to be in y equals mx plus b form. Okay? We need to get y by itself. So let's take care of the bottom equation first because that one's going to be easier to solve. So how do I get y by itself in this bottom equation here? Hopefully you said you're going to subtract x from both sides. So we're going to get y equals negative x plus 2. I'm going to draw a little arrow over here. Rewrite the new equation over here. Negative 2x plus y equals 5. How do I solve for y in that top equation? Hopefully you said add 2x to both sides. I get y equals 2x plus 5. Okay, so the bottom equation I'm going to I'm going to draw a blue line for, and the other line I'm going to draw a green line for. Okay, so you know which ones are which. Okay, so I want to graph y equals 2x plus 5. So first point we graph is our b, right? What's our b, 2 or 5? Our b is 5. We're going to go up 5 or down 5? We're going to go up 5. Positive 5 means 1, 2, 3, 4. Is that 5? 1, 2, 3, 4. That's 6. Whoops. 1, 2, 3, 4. 5 is right here. So our b is up 5 or down 5. It's negative 5 would be going down 5. That's the first point you're going to graph. Okay? Then what you're going to do is you're going to use the slope to find other points on the line. So our slope for this one is 2 over 1, right? So we're going to go up 2 and over 1. So we're going to go up 2 over 1. And we ran out of room, so instead of going up 2 right 1, we can also go the exact opposite direction, which is down 2 left 1. We can keep going down 2 left 1 for a while. And you're going to want to go all the way across the graph for these lines because we're not sure where they're going to cross if they do cross. So it's going to be important to draw the lines all the way across here. All right, now the blue line. We have y equals negative x plus 2. So what's our y-intercept? Our b is going to be 2. So we're going to go up 2 and put a point. And then what's our slope telling us to do? Our slope, what number's in front of the negative x there? That's a negative 1. So we're going to go, negative 1 over 1 means a rise over run of down 1, right 1, right? Negative 1 over 1 is, it's down 1, right 1, right? So we're going to go down 1, right 1, keep going down 1, right 1. And you can kind of see I'm going to keep going down 1, right 1. But this is why we need to go the exact opposite direction. Instead of going down 1, right 1, we can go up 1, left 1, right? The exact opposite direction. You can see they're going to cross right here. And that's why it's important to go all the way across the graph. And you can see the solution is going to be where they cross, and they cross right here, which is the points negative 1 and 3. All right, we're not going to check our solution, but you can check your solution by plugging in x and y. Okay, if you plugged in x and y, you would see that it's going to be true for both original equations or the final equations that we came up with, okay? All right, moving on. Got 2 more examples and one little thing at the end here, so let's keep moving, trucking away. All right, we have 2x minus y equals 2 and y equals 2x plus 3. Okay, So the bottom equation's good. Let's use green again for the bottom. That one's solved. For the top equation, we have to get we have to solve for the top equation. So we have 2x minus y equals 2. So how do I get y by itself here? What am I going to do? I'm going to subtract 2x. So I have negative y equals negative 2x plus 2. Now what do? Divide by negative 1. So I have y equals, because negative y, the way you get rid of that negative is dividing or multiply by negative 1. Negative 2x divided by negative 1 is positive 2x, and then positive 2 divided by negative 1 is minus 2. I think I goofed up my problem here. Did I? Yeah, I think I messed up my problem on the actual sheet, so whoops. All right. We'll keep cruising away, though. Let me just double check my work here. So we subtracted 2x. We divided by negative 1. So yeah, it should be 2x minus 2. Okay, I put 2x minus 1 on my paper. So we're going to use blue for this one. All right, let's graph the blue one now. Let's see what happens. 2x minus 2. So we're going to go, our b is 2 or negative 2? Our b is negative 2. So that up 2 or down 2? That is down 2. We're going to go down 2, put a point. What's our slope telling us to do? It's 2, so up 2 over 1. Rise of 2, run of 1. You could also go down 2, left 1. And we're going to use the graph the green one then too. All right, now we have y equals 2x plus 3. So where are we going to go for, what's our b? Our b is 3, so we're going to go up 3, put a point. And our slope is telling us to go up 2 over 1. And we ran out of room, so we can go, instead of going up 2 right 1, we can go down 2 left 1 to keep in line with the rest of the graph. Go all the way across. What kind of lines are these? Do these lines, so solutions are where they cross. Do these lines ever cross? No, they do not cross. So how many solutions do you think there are if they don't cross? This is called no solution, because they're parallel lines. They never cross. Okay, so solutions are where they cross, and they're parallel lines, which are by definition never going to cross, then they have no solution. Cool, cool. All right, we got one last different type of example here. Let's use black like my soul. Sorry, that was just a little morbid, but all right. Okay, so the bottom equation is good. I'm just going to rewrite it. So we have negative 6x plus 2y equals 8, and y equals 4 plus 3x. We like to write mx plus b, so I'm going to rewrite this as y equals 3x plus 4. And that's the green line we're going to draw. Now let's do the top equation. I'm going to write it over here. Negative 6x plus 2y equals 8. All right, so now we need to solve for y. How do we solve for y here? First step, we need to get that 2y by itself, so we need to add 6x. So we have 2y equals 6x plus 8. Now what do? Divide by 2. Y equals 6x divided by 2 is 3x. 8 divided by 2 is positive 4. Ruh-roh, what do you guys notice about these? It is the same exact lines. I'm only going to draw one line here because they're literally the same line, but let's go ahead and graph this. So we have y equals 3x plus 4. So we're going to go which direction to plot our first point? We're going to go up 4, put a point. What's our slope telling us to do? We're going to go up 3, right 1. Rise over run of 3 over 1. We can go down 3, left 1. Down 3, left 1. And what the heck, I'll draw a green line on there too, just for funsies. Okay, it's the same line on top of itself. So how many solutions are there? If it's the same line on top of itself, how many times do they cross if it's the same line and going on forever? Well, they cross infinite times, right? Because it's the same line. It's going to be, each line is going to line up and cross itself infinite times. So this is going to be infinitely many solutions. Because it's the same line. And they cross infinite times. Okay? If they overlap, every place where they overlap, this is going to be a solution because that's where they cross. It's not really thinking of them as like crossing because they're on top of each other, but they are crossing when they're lining up like that. So yeah, this is going to be infinitely many solutions because it's the same line. All right, so let's go ahead and review the end here. Use a nice burnt orange. Okay, so if the graph is a pair, it says when you graph a linear system of equations, 3 situations can occur. If the graph is a pair of intersecting lines, then the system has how many solutions? Well, intersecting lines was like up here. It looks like they cross once, so how many solutions are they going to have? It's going to be 1 solution. Also, I forgot to mention, we'll talk about that a little bit later here, but we'll talk about that in a second. Okay, so intersecting lines have 1 solution. And then we have parallel lines have no solution. Or what I meant to draw earlier is this circle with a line through it. It's called the null set. The null set. That means that there's no values inside the set of numbers there. Okay. And then we also have coinciding lines or the same lines. And that's going to be infinitely many solutions. Okay, so hopefully, sorry, I kind of got away from explaining how to take notes on this stuff here, but I would do the solving and the graphing, and then maybe at the end just write a little example like this at the end of this kind of stuff, so you kind of know what the different operations, what the different possible solutions are for graphing systems of linear equations. Okay, but hopefully that was a kind of a review from Algebra 1. Thank you guys for watching. Have a great day, and we will talk soon.